To the learning of computer networks and security. We are going to start with the module 5, that is multimedia networking. We will just start with the fixed playout delay. How at the receiver end jitter can be removed with the technique of fixed playout delay we will be discussing here. As we know here, at the receiver end, immediately after the audio is received, he begins to his playout. So as and when the chunk or the audio is received at the receiver's end, he begins to play that particular chunk. So now we can just assume that receiver is receiving each chunk exactly at after q milliseconds. So it is something like sender is sending a audio, or he is sending a chunk. Let's call that audio as a chunk, okay, C1, and that chunk will be sent by adding a timestamp, say T. Now that chunk will travel all the way in the network, and the time taken to travel there in the network, let us take it as q milliseconds. And now here at the receiver's end, the chunk is received, that same chunk C1 is received at time, say R. So here we can just take this as Q as nothing but the time taken by the chunk to travel all the way from sender to receiver, and R is the time at which the receiver receives that particular chunk. T is the timestamp at which the sender sends that particular chunk. So let us take this Q, parameter Q, as it should be less than 400 milliseconds. So let's call this Q as a delay. So this delay should be maximum, it can be 400 milliseconds. If it is greater than 400 milliseconds, then the receiver will be able to will be actually experiencing disturbance. So here if the Q duration, or if the delay here is less than 400 milliseconds, then the receiver can accept that chunk, or he can start his playout, or he can continue his playout without any disturbance. Okay, so this Q now I can define as, this Q can be defined as R minus T. So what is R here? R is the receiving time and T is the sending time. So Q is a gap, right? So here or also you can reframe this as R receiving rate as Q plus T. This also can be rewritten. So just a rearrangement, right? So now okay, so what is the trade-off in choosing Q? What should be this Q? So for the receiver to begin his playout, it is all dependent on this Q. So for the receiver to continue his playout without any disturbance, it all depends on this Q. So if the jitter is less, definitely the receiver can smoothly play the audio. So here what should be the value of this Q? What if the value of Q is too large? So what is the meaning of Q? It is nothing but the delay, and if the Q value is too large, in that case definitely there are less chances of packets getting lost. So what is the meaning of that? It is something like, if the time T, you take it as T as, say for example 20 milliseconds. After 20 milliseconds, say the sender is sending the chunk, and maybe the time taken by this packet to reach the receiver let me take that queue as, say, it will take another 20 milliseconds or another 25 milliseconds to travel all the way in the network and reach at the receiver end. So what is R now at the receiving time? That is equal to 20 plus 25. So after 45 milliseconds now the receiver is receiving, right? Something like that. So now if you choose this Q value as a very large value, so there actually the meaning is there is some time at the spent here, there is some time at the for the receiver to play the chunk. So this is about the first chunk. What about the second chunk again? If the second chunk is again received there after 25 milliseconds, there the gap is fixed. See, first chunk is receiving after 25 milliseconds. The second chunk also is reached at the same after duration, that is again after 25 milliseconds. In that case the receiver can continue his play out with the constant gap. So what is that? First chunk is played after 45, after 20 plus 25, that is 45 milliseconds. The second chunk also is played at the same duration, right? So after 45 milliseconds of gap only the second chunk is played. So here if all the chunks are received with the fixed gap, with the fixed queue, in that case you can call you can just say that the receiver can play his audio chunks with the fixed gap, fixed delay, right? So what if this delay is too large? In that case the less number of packets may be lost. So it is something like if you keep this duration as too small duration, if you keep this Q value as too small duration, in that case there are high chances of you can just say that the interactivity increases. So better interactive experience between sender and receiver. So what is the meaning of that? If the Q value is too small, what is the meaning? Sender can very quickly send the data to the receiver. So in that case the receiver also can quickly begin his playout. So this will be, interaction will be better. So if the value is very large, in that case the packets, less chances of packets getting lost. Why? Because here all the time the there is lot of time for the packet to move through the routers and to reach at the receiver end. So less number of packets may get lost there. We can now analyze this jitter with the help of a graph. So what is this graph saying? So this graph is basically showing you, it is a smooth graph. You can just see here at time, the first instant of time t0, like we can say at time t0 here, the first chunk is sent from the sender side, and after certain duration, that is at time t1, say the second chunk is sent. Next after that third chunk is sent. So everywhere this horizontal gap, what we can see is nothing but the gap or the duration spent or the, you can say, the time duration between the subsequent chunks. That gap or the time duration between subsequent chunks is actually fixed here at the sending side. And now let's see here at the receiving side. How exactly the chunks are received at the receiving side? This black graph, you can see it is saying about the receiver. Now here let's take this time, or let's take this particular time as t, the time at which the sender is sending, and this particular gap what we have to take that as q. And now this, the time at which the receiver has received the first chunk, let me take it as r. So q is equal to r minus t, right? So here when the receiver is receiving his first chunk, after that maybe you can see his playout begins, and here you can see what is the gap there. This is the time where the receiver is receiving the second chunk. So the second chunk and the first chunk, when he is receiving, there is a little more gap. And now here this is the time duration where he is receiving the third chunk. So the gap between the second chunk and third chunk, this gap, horizontal gap, is very, very less. So what is the meaning of that? Here the network delay is varying. That is because of the jitter. So here varying network delay because of varying queuing capacity of the multiple routers here in the network. So everywhere the network delays are varying. So what happens to the playout at the receiver side? So this playout also at the receiver's end varies, and definitely our receiver also will experience disturbance. So now how to make it as a fixed delay? Clients play out a delay. You just see how the client has to decide his delay, fixed delay. So in order to get this experience of smooth play out, so in order to get this experience of smooth play out, we'll just see the parameters. So here, if the difference, and that difference, let me take it as difference between the subsequent chunks. So first chunk you play and the second chunk you play, that gap between the two chunks when you play the video, if that is more or less than 20 milliseconds, this is what the graph is shown for that. So between, with the gap of 20 milliseconds, if the receiver is trying to play his received chunks of audio with the 20 milliseconds of gap between the subsequent chunks, if the receiver is playing his audio again, right? So in that case, you can just call that as a smooth playout at the receiver's end. Smooth playout at the receiver's end. We will see how to calculate that. You can just see here the fixed playout delay. So actually we will take an example. Sender generates the audio and he sends it for every 20 milliseconds he sends the chunk, depending upon the talking speed. So the talking speed is talking speed which keeps on varying, right? Okay, so now I want to fix one parameter for that, for playing that audio. So first the packet is received at the receiver's end at time R, like how I showed it earlier. And now let's take a new parameter called P, where a receiver will start his playout. Receiver will start his playout. So in fixed playout delay, actually different schedules are fixed. See, this is the first playout schedule. What is the meaning of first playout schedule? The first you can say the first parameter he's fixing now, or that fixed value whatever he has to take, or that gap whatever he has to maintain between in every chunks that is playing, that gap should be fixed here. That is the aim, right? So in order to fix that gap in one iteration or in one schedule, that is not possible. So he has to go for multiple such schedules. So let's see that receiver is fixing one delay, and he is fixing with that delay he is beginning his first playout schedule. And we'll see what is going to happen. See, this is the sending rate where the gap is fixed. So between the chunks, whatever the sender is sending, that gap is fixed. Now all the way the packets are traveling at the receiver's end. And at the receiver end, R is at time R, actually he is receiving his first chunk, and now the playout begins here exactly. The playout begins, a pink dot you can see, and the playout of audio begins at this particular point of time. That means he has waited after receiving the chunk, he has waited for some amount of time, a small gap he has taken, and after that he has started his playout. And you can see now from this point of time, he has waited for some duration there for receiving the next chunk, right? So he has waited for, say, around for example maybe that is less than 20 milliseconds there. It is less than 20 milliseconds, since this gap he has waited for some duration maybe. Okay, and now at this point of time is receiving second chunk, right? So here again this gap whatever he has taken is fixed. Maybe he has waited for around 15 milliseconds. That gap he has fixed, and now he has started his next playout. Again, that same gap, 15 milliseconds he might have maintained, and he has played the third chunk. And you can just see here whether the third chunk is received. The third chunk is received. Third chunk is received over here, but maybe it is not received completely. You can see there's a long gap. Okay, third chunk is received maybe, but the fourth chunk is not received here after 20 milliseconds of third chunk. So here the receiver is receiving first chunk, after 20 seconds maybe second chunk is received. But immediately there within less than 20 milliseconds third chunk is received. You can see then less than 20 millisecond gap third chunk is received. But after long gap here fourth chunk is received. But what about this fixed duration? What the receiver has fixed duration for his play out. See, but after playing three chunks, but for playing fourth chunk, whether he is able to retrieve that chunk? No, he has not yet received. He is receiving that fourth chunk over here after long time. So this is a packet loss, what receiver is observing, what receiver is experiencing. And now you see that fixed duration, since it is fixed, it is continuing his play out. Receiver is continuing his play out. And after that fixed duration, he is trying to play next chunk, fifth chunk. Whether that fifth chunk is available, definitely. That fifth chunk has come now. And now sixth chunk. So this goes on. Because of this fixed delay, what is happening? The receiver is receiving or experiencing loss here. So this is his first playout schedule. Now what is he doing? His playout he has started here somewhere, right? Which is greater than the receiving time. After he receives his first chunk, he has fixed his playout schedule. Now he is fixing the next playout schedule, which is slightly larger again, which is again in P dash he is fixing the next playout schedule, which is greater than the previous playout schedule. So that means if this is 100 milliseconds, this is maybe 200 milliseconds, something like that, right? After 200 milliseconds is going to begin the playout. And now you see after 200 milliseconds already many chunks would have been received. See here, when he started his playout, maybe at 200 milliseconds, maybe two chunks he has received. He has started his playout. We can just continue there. We have the next playout schedule, as I already said, it is say suppose this is 150 milliseconds. Here by this time already two chunks are received. So easily he can play the first chunk. And here by the time he reaches after setting that fixed duration, he has now started playing by this time second chunk. So definitely the second chunk also is received. So after certain duration of gap, he has started with the next chunk. So you can just compare here, third chunk also is received. By this time you can just see the next one. By that time the next fourth chunk also is received, and by this time actually next chunk also is received. So this is the next playout schedule where that P dash what he has started is slightly late, that is which is greater than the first playout schedule, and by then you can see here all the chunks would have been received and the receiver can play. So we have the next type of playout delay at the receiver end, and you call that as adaptive playout delay. So what is this adaptive playout delay? So we know that the talking spurts varies, right? So what is the meaning of talking spurt? It is talking speed. So we have in the sender speaking, sometimes there is a pause or there is silence in between. So sometimes the talking speed is very low, sometimes the talking speed is very high. So in that case, whenever the talking spurt varies, actually the receiver's playout also should be adjusted accordingly. So receiver's playout should be same as the sender's talking spurt, right? So there should be synchronization. So how one can manage that? So how, as and when the talking spurt varies, actually the receiver should be able to perceive that, receiver should be able to find out that, notice that. So how this can be done? So here, say suppose whenever there is a silence, In this adaptive playout delay, actually, that silence is actually compressed, or the pause that what you have, that is compressed. Okay, that see, silent periods are compressed and it is elongated. So that is how you are adjusting. And whenever the talking speed is high, there is no silence, no pause there. So there also those chunks will be played. I mean, those chunks will be sent back to back. And in all the cases here, just see here, the chunks in first case also, whenever the talking spurt is low and whenever there is silence or such pauses, the receiver side chunks should be played maybe for every 20 milliseconds. Okay, so for every 10-20 milliseconds without any disturbance. In both the cases, receiver should be able to play without any disturbance. Now here, let us see. In the adaptive playout delay, actually we are calculating something called as network delay, average network delay. So what is that? See, sender will be sending varying audios at varying speed. So here some slow set of audios in the sense slowly the chunks are transmitted. When the talking spurt is high, the chunks are transmitted at higher rate. So in both the rates, actually what the receiver should be not experience all that. Receiver should be able to play out without any problem. So in both the cases, actually the average delay is calculated, average network delay is calculated. So that is something like you are adjusting the playout delay at the receiver end. You are adjusting the playout delay at the beginning of each talk spurt. So initially, based on this, by keeping this first chunk what the sender is sending, keeping that as a reference, average network delay is calculated. So that based on that average network delay, the playout duration is adjusted. Okay, so that is done at the receiver end. So we will take an example and see. So here one small algorithm is taken to explain this adaptive playout delay. So what is that algorithm, we will see. So simple. So first let us take a parameter t. So here ti in general, let me take, that is nothing but the time at which the sender sends the chunk, each chunk. So t1 indicates the time stamp of a packet, the time the packet was generated by the sender. You can say this is the time taken by the sender to you can say the time taken by the sender to send this packet, generate and send this packet. So ti. So next we have ri, the next parameter. So the time at which the packet I is received by the receiver, each packet. Okay, and then we have pi. This indicates the playout time, that is the time the packet I is played at the receiver's end. Okay, so this ith packet, every packet should be played at the receiver end, and this is the time at which each packet is played at the receiver end. So these are the three packets we're going to, three parameters that we have initialized, that we're going to take initially. And now the end-to-end network delay, end-to-end network delay in the sense the delay between the sender and receiver, we define it as Ri minus Ti. So what is Ri minus Ti? The time at which this receiver is receiving the packet and the time at which the sender is generating the packet. Okay, so that gap, Ri minus Ti, we call it as a delay, and that delay we can define it as Q, right? And that we can denote it as Q. Now it is this delay Q whose average we have to calculate. So how do we calculate that average delay? So average delay, we'll have a formula now to calculate that. Let's denote that as D. So D is actually you can call this D as delay estimate, or average network delay, average network delay, which you can calculate by taking a constant, say alpha. So this alpha value, constant value, you can simply take that value as 0.1, or also you can take it as 0.01. Okay, 0.01, that parameter you can take it as 0.01, very small constant, negligible one. And this di minus 1 is nothing but, this is actually the delay that you have taken based on the, or you can call this as a previously calculated delay. Okay, so whenever you are calculating the average, remember you are going to consider all recent packets that you have received, not the very old packet. So this di minus 1 is the previous, that is the recent average that you have calculated for the recently received packets. Okay, and this plus you add that with alpha again, multiplied by Ri minus Ti. What is this Ri minus Ti? This is nothing but all the previously received packets duration subtract from the previously sent packets. All those recent packets delay you take up and add it with the previously calculated average, and this is how you calculate the new average delay for the received packet. Okay, so upon receiving the packet, now you have calculated this average delay. So this is the first step that of the algorithm that you have made. Now, so this delay alone, average delay alone may not be enough. So because between the sender and receiver, this jitter keeps on varying, or the delay keeps on varying. So that is why apart from this average delay, we also require to calculate one variance there, and that average deviation of the delay we have to calculate. So we have a parameter for that. We'll see that. As I already said, now we have to calculate the deviation, that is average deviation of the delay, and we denote that as Vi, which is now dependent on what? The previously calculated average delay. Suppose if there is any variation in the previously calculated average delay, we are going to again calculate that by using a formula 1 minus beta. Beta is a new constant now that you have taken, and that 1 minus beta multiplied by previously calculated variance plus beta into this recently received set of packets, I mean that delay Ri minus Ti, subtract that from the recently calculated average. Okay, recently calculated average. So this value what you're getting is the variance, or you can call that as estimated average delay. Okay, so now what we have done is we have calculated Di and Vi, and this we have calculated for each and every packet that you have received. Correct? And now as per the algorithm, as I already said, all your delay here, this is adjusted by keeping the first packet as reference. Now your first packet you have received at time R1, and the first packet was sent at time T1, right? And the now you have to fix up the playout time. So how you should calculate the playout time? So the playout time what you are calculating now is based on the first packet that you have that was sent, so T1, plus the average delay that you had calculated for that, plus k times, you can take the value of k as 4 or something, 4. So 4 times you multiply by the variance. Okay, so by doing this, what you're doing is actually you have already calculated the variance, average, and you know the first packet sending time. Based on that, you are now fixing your playout time. So in your graph, what is that playout time? That is the time at which you have to begin the playout at the receiver side. So that playout time you are now fixing by using this formula. And now you don't think that this playout time what you have calculated is fixed. No, it again varies. So how is that varies? That varies based on your gap delay. So what is Q actually? Q is actually calculated by Pi minus Ti. So what is that Qi, Pi minus Ti? This is nothing but the time taken, time at which the receiver has started his playout, and the time the sender has sent his audio. So Pi minus Ti is nothing but Q. So I guess somewhere I made a mistake while telling. Actually, there it is not R is equal to Q minus, sorry, it is not Q is equal to R minus T. Okay, I'm sorry. That is Q is equal to P minus T. So what is P minus T? It is nothing but the time taken or the gap from the play out to gap between the play out and the sender's sending time. Okay, so that gap actually you call it as, you take it as Q. Okay, note this. And now since this gap keeps on varying for different packets, now whenever you're calculating the playout time for the next one, so what you have to do, all that you have to take reference for the first packet. Now you are calculating the playout time for the second packet. This is for the first packet what we calculated, right? Now when you calculate for the second packet, the playout time formula is the playout time of the first packet that you have just calculated just now. So that playout time you have, okay, or you can take this as playout time, or else the formula would be something like this. So when you calculate now the playout time for the next packet, Pj, let me take, which should be equal to the sending time of that particular packet plus, already we know what is Q, right? What is Q? The playout time for the first packet minus the sending time of the first packet. So it is enough if you add that delay directly to the second packet's sending time, right? So this is actually the time duration gap, time gap between the first packet playout and that gap of first packet's playout we already know. So that Q gap you add with the second packet sending time, you know, with which you can calculate easily the second packet's playout time. This is a second playout time, right? So this is how you vary the playout time. And this variation you may observe if this gap varies. What is that gap? That is the gap between the playout time and the sending time. If it keeps on varying, you may get a big variation, big gap between the playout time of previous chunk and the next chunk. Okay, so this is how the adaptive playout means. What is that adaptive playout means? It is depends upon the varying network delay. Okay, and it also depends on the varying talking spurts. So this is how you have to calculate. So remember, Q is actually P minus T. P is the playout time of the sender and T is nothing but the time at which the sender has sent. So P minus T. So this is all dependent on the network delay there. So if the network delay is too high, this Q value will be high. If the network delay is less, the Q value will be less. So Q value should be as large as only 400 milliseconds for the receiver to have smooth playout, right? So this point you will have to remember. So first we are calculating the average D based on all recently received chunks, and then after that, that is average actually what you're calculating, and then deviation in that average again we are calculating, that you call it as V, and that we have calculated using this formula by taking the previously calculated average. And finally with the help of that you now fix the playout time of the chunk. Playout time of the chunk is equal to the sender's sending rate, and then the average, and then finally the variation in the average. So this is actually finally what we say. This is a small question we have. This is self-study. So what you can just go through this. How does the receiver find whether the packet is first in talking spurt? So how you can come to know? So just compare the subsequent packets that is received or chunks that is received. If the gap between the subsequent chunk is 20 millisecond, and you can just say that the talking spurt has just begun. Okay, that is just started. So if assume that the gap between the subsequent chunks received is just 20 milliseconds, or if with that alone you will not be able to find out which is the first chunk received at the receiver end, you can even go with the sequence number. If the first chunk sequence number and the second chunk sequence number is continuous without any gap, and plus the duration Q value also is 20 milliseconds, then you can just identify that the talk spurt is just begun. Okay, so this is how receiver will find out which is the first chunk that is received.